All right, I think we're going to go ahead and start. Hello, everyone. I'm Mike Tsang. I'm the Applications Engineering Manager for Rapidform. And for today's webinar, we're going to talk a little bit about Rapidform XOR and LiveTransfer to Creo Parametric. Now, some of you may already be familiar with XOR and how we can create parametric models from scan data. And we'll go over some of that today, but the main focus will be how to take that parametric model and transfer it into Creo. If you do have any questions, feel free to write them into the webinar system there, and we'll try to get to them at the end of the webinar, or we'll follow up with you individually. All right. Now, you've probably already heard that Rapidform is now part of the 3D Systems family. 3D Systems, of course, is the leader of 3D printing and materials and services, and we're now part of that family. Specifically, Rapidform is now 3DS Rapidform, but we still have the same ideas, innovation, experience that you expected from us before. We've been developing the software since 1998, and we have more than 10,000 licenses sold. So we definitely know what we're doing. We're also always innovating. We have at least 40 R&D staff developing for the software, and we're kind of the inventors of the modern scan-to-CAD method. Not only that, but we have a strong support staff. In-house, we have 30 engineers dedicated to customer support, and worldwide we have over 200 resellers that are certified to train and support our customers. And now that we're integrated with 3D Systems, we now have the strength, and we're listed in the New York Stock Exchange as DDD. Here's just a broad sample of customers who use XOR. From video games to automotive, aerospace, and consumer products, you see we've been integrating almost every industry out there. Now, we call Rapidform XOR the fastest path to CAD. What does that mean? Well, basically, you're going to take scan data that you obtain using a 3D scanner, and you're going to place that into XOR. And what XOR is going to be able to do is create a parametric CAD model from the scan data, all in one system. We have all the mesh processing tools, we have the scan data itself, and we have CAD tools for you to create an accurate parametric model. We know it's going to be accurate because we also have an Axor analyzer, which allows you to check the accuracy of your model against the scan data. And then once you've completed your model, you can go ahead and export that into your native CAD system. That's SolidWorks, Creo, NX, Inventor, and the list goes on. So why do we say that we're the fastest path to CAD? Well, we did a little benchmark, and we took apart, it looks like this pillar right up here, and we tested to see how long it would take to reverse engineer that part using just CAD software and your traditional calipers and tools. We found it took about 12 hours to get something like that into your CAD package. Now, if you were able to get some type of simple 3D scanning software, by that we mean something that you are able to get the scan and extract maybe curves or nerve surfaces or reference geometry, and you try to do it in your CAD software, it still took about 6 hours, and there was a lot of back and forth between the two softwares. Now if you take that scan data into Rapidform XOR, we could take that model and get it CAD'd up in about an hour. That's dramatic. That's pretty fast. So this is why we call ourselves the fastest path to CAD. And we're not the only ones saying that. In an independent study done by the U.S. Air Force, they made the conclusion that Rapidform is the only viable choice for parametric solid modeling in support of 3D shape engineering and design. That's huge. We use someone else other than us also agreed that we are indeed the fastest path to CAD. And of course, you can find that study on a website if you want to read a full description on it. Now, let's talk a little bit about the XOR workflow. We're going to take an example from a well-known customer. I think everyone knows about Jay Leno and his garage. And Jay Leno in his garage, he has a wide variety of cars. And one of his most recent purchases was 35 Fraser Nash. Now, he needed to get parts made for this guy to renovate it, and one of the parts in particular is this thermostat housing. You can see the original on the left side has been eroded, and is not the best part to use. So by using XOR, he's able to create an accurate model based from the old part that he can now actually use in his new part. Now let's go into more detail about how we did that. So we took that model and we took that old part and we scanned it to create a mesh. That's what you see here. The next step after that was what we call region grouping or feature recognition. And basically just going in and identifying simple geometry. What are planes? What are cylinders? What are revolves? And with that basic geometry, we can go ahead and do an alignment, and we can break down the feature part by part so that we can start modeling this thing up. So once we've done that, we go ahead and start creating our sketches. Very similar to what you would do in Creo. Create your sketches, and what's nice is that we can do it right off of the scan data here. You can see that we can take cross-section out from the scan data, and we can use the scan data to check accuracy, so that when you create our features, which is the next step, we can make sure that they're accurate and that they're designed the way that we want them to be designed. So just like in another CAD software, you can go ahead and create your features piece by piece, and then add details, fillets, chamfers, small little features, till finally you have your finished CAD. Once you have that, you can go ahead and live transfer that to the CAD system of your choice, whether it be Creo, SolidWorks, or NX. Of course, you can also export it as one of the universal file types like IGES or STEP. All right, now let's actually show a demonstration of this. All right, what we have here is a poorly scanned probe plate. It's poorly scanned on purpose just so we can show the strengths of Rapidform XOR. Basically, we don't need to have perfect scan data. We can go ahead and create parametric models just off of what you see here. Now, I've already modeled a majority of the part. You can take a look on the left. You can see my feature tree. And we can see the sketch, the main sketches, an extrusion, additional sketches to cut out the holes, and another extruded cut, so on and so forth. And on the right here, you can see our action analyzer, and this, of course, shows us the deviation between our mesh and our CAD. So if I turn that on, I can take a look, and right off the bat, I can see some areas where I hadn't completed the feature yet. So I'm going to go ahead and complete the part, and then once we're done that, we're going to go ahead and do a live transfer to Creo. You can see here in the colors, this is basically showing that region group. It's identified our basic geometries. We've got cylinders, planes. What I'm going to do is I'm going to make a cut right off of this for this section out here. And if we take a look, this bottom side is actually the table on which it scans. So we're going to make a nice through cut for this part. And what we're going to do is start off with a sketch first. So I'll go ahead and come up here and select sketch. Now you notice that I have two sketches here. We have a regular sketch, which is your regular 2D sketch that you would do in any CAD, your lines, revolves. But the mesh sketch has those tools, including the ability to snap on to the mesh itself, so taking a cross section and then creating sketches on top of that. So we're going to use mesh sketch, and I have a plane set up here for us. We take a look at that plane. You can see the initial cross section off on that plane. You have some data basically from off the wall. And what we're able to do is able to move where that cross section takes place. So as I move this, you can see that the cross section is being taken place at a different spot and projected back onto that sketch plane so that I can design my model for that plane. So we're going to just put it in the middle here. And if I hide my mesh, you can see the outline of our part. Now, as I said before, we're going to go ahead and create a through cut through the whole thing. So I'm going to design something, basically just a simple trapezoid there, and to create the lines. Now you notice that as I move my line tool over areas, that it's automatically going to fit to the scan data that I have in place. So this is a fantastic way to quickly model the geometry needed to create my feature. And I know that there seems like a lot of tools up here, but these are all tools that everyone's familiar with. You have your line tools, rectangles, circles, trim tools, which I'm about to do right here. Go ahead and trim these guys together. So it's all very familiar tools that users of CAD will be familiar with. And once we have our part, our sketch, we're going to go ahead and make an extrusion. Just use the extrude tool. Come out here. And you can see that I can go ahead and ask it what distance I want it to go through. If I want to do a merge or cut, in this case I'm going to go ahead and cut it. And we have the ability to go different methods that you'll be familiar with, blind up to particular surface or body, or through all. Now we don't need to go through all, we want to come here. And if you notice that we can not only use the mesh as a visualization to figure out how far we want this to be extruded to, but if we turn on our region groups, we can actually use that information to ask it to do cuts. So if I were to ask it to create that cut up to this part of the region, it's going to be able to do that and create the distance necessary to perform that cut. I'm going to go ahead and accept that. And we'll go ahead and hide this mesh and take a look at our solid body and see that it indeed made that cut for us. Now I'm going to very quickly go ahead and check our Axis Analyzer, verify that it looks pretty good, and notice that we do need one more feature down here, so we're going to go do that as well. Now I'm going to go ahead and create a plane to base my sketch off. I'm going to base it off this freeform here. And what you can see here is I have the ability to actually constrain the axis in which that plane is created. Scan data isn't perfect. Parts aren't perfect. If I were to extract a plane from the side here, who knows if it's going to actually be perpendicular to my base planes or recording system. What I can do is go ahead and say, extract a plane from here, but make sure that the axis is straight in a certain position. So I'm going to say, ask it to do Y, so that we know that's going to be perpendicular to our main planes there. Go ahead and create that. And we'll just have that. We'll go ahead and do another mesh sketch off that plane. Just like last time, I'm going to go ahead and adjust where my cross-section is being taken, so I can capture good data. And just like before, we now see an outline of what we want to cut. And I'm just going to use the circle tool, and it's going to best fit a circle to that data. Now, if I wanted to put design intent, let's say we can take a look, see what this radius of the circle is at 3.1775 inches. If I wanted to go ahead and say, no, I want it to be rounded in one direction or another, I can go ahead and manually type in numbers to do that. XOR allows you to put design intent in any of your models, so that you don't have to create, you're not restricted to the mesh. You can actually put in design intent. Just hit OK from there. And just like before, I'm going to go ahead and do an extruded cut. So, extrude tool, select my sketch. This time we know that it's going to cut through all. There's nothing on the other side, so we'll just go ahead and put the distance farther than that, select cut, and take a look at our part. All right. At this point, we're going to go ahead and do a live transfer to Creo. And to do that, we're just going to go to File, Live Transfer, Creo. And what it's going to do is it's going to go ahead and launch Creo for us, and then it's going to basically use the API given by Creo to generate the model. So you can see there that on the left, our model tree has been filled out, and right here we have our completed part. The model still has its parametric model tree. I can come in here and edit these sketches if I wanted to, change things around, make new dimensions, all within Creo. It's now a native Creo file. And we've transferred our feature tree from XOR into Creo. Now, of course, Creo has many CAD tools, and so does Rapidform XOR, but they may not always share the same capabilities. For example, things like Booleans. We're able to do Booleans in XOR, but you may not be able to do that in Creo. Along with some limitations to the Creo API, we're not able to transfer all commands or features. But if we take a look, launch our help guide, you can see that we actually have a table to show you, just what features you're able to live transfer from XOR to Creo. So if we take a look under the Creo column here, you can see one of the things that's not supported is doing an offset from Solid. We're able to do that within XOR, but for whatever reason, we're not able to put it through Creo. Now, we can use, you can see this is an extensive table. You can use that table and have it up, or within Rapidform, we have what we call the error list. So go to the error list here, let it launch up. You can see that we can actually have it do a CAD compatibility check of different CADs. So if we choose Creo, if there was a feature in here that Creo did not support in the live transfer, it would actually pop up to let us know. So as we are designing the part, we're not left guessing to figure out, oh, will it live transfer correctly? We can actually see if it will. And just to kind of show you, I'm going to go back in here, and instead of doing a cut, we'll say create a separate body and do a Boolean cut. I know this is going to be supported, so select that as our tool, anybody as our cut. You see, as I finish that command, it gives us a pop-up letting me know that this Boolean cut is not a supported feature. So with that, I can go ahead and decide, okay, well, maybe I need to do this cut in a different way. All right. I'm going to bring in another file here. I'm going to show you, what happens when XOR uses tools that, we obviously have the mesh in front of us, and we're going to use a lot of the mesh to help us generate our features. What happens if, obviously this mesh isn't in Creo, so how does Creo create geometry that doesn't exist? And basically what we're able to do is create interim geometry from, from one software to the other. So even though you don't see that interim geometry in XOR, it's going to automatically be created in Creo for us to help with the creation. In particular, we're going to talk about this freeform top here. You can see that it's a nice freeform shape. And if we roll back, you see our first command was just an extrusion. But you notice if I edit this feature that it's an extrusion up to a particular region. And we were able to take that region and ask it to trim it to the top surface there. So it does an extrusion and trim all in one shot. Now, of course, because, again, Creo doesn't have this mesh available in the file, we're going to ask, how's it going to do that? I'll show you. So you're going to go ahead and perform live transfer of this part. Take a look what happens. So here again, we're doing the live transfer into Creo. It's generating our parts. On the left side, the model tree is being populated. All right, it's done. I'm going to go ahead and hide some of these reference geometries for us. What you can see here is that automatically, during the live transfer process, a freeform surface was created, or imported, I should say. You can see this is imported feature, in order to go ahead and complete the feature cut. So basically what Rapidform did in the background was created this freeform surface from those regions and then transfer that into Creo for us so that we could use it as a cutting tool. And that's how it went ahead and generated a part like this. Right. Continuing on with the presentation here, I just wanted to show you some of galleries of examples that we've done. This is just a quick sample, but it gives you a good idea of the different industries, what we're capable of. Of course, here's an automotive example. Not only the exterior, but also internal components, camshafts, engines, exhaust manifolds. Examples from the aerospace or transportation, we've done boats, helicopters, planes, space shuttles, as well as many consumer products from your phones to your sunglasses, cases. We're able to do tooling, molds, and much, much more. As you can see, Rapidform is a very, very powerful tool. It can be used for many applications in many industries. And go ahead and close it up. Thank you for your time. If you have any questions, go ahead and ask them now, or I'll go ahead and take a look at that. And with that, I'm going to open it up. Shane, he's assisting me here in this webinar. Do you have any questions?
Yeah, we do have a couple of questions here, Mike. Thanks for the presentation. The first question I have is regarding training. What options does Rapidform offer for training?
It's a great question. We hold Rapidform training at least every month. At the beginning of every month, first week, full week, we do Rapidform training, usually at our Denver office. So if you go to our website under support, you can take a look at the calendar and, of course, register for the training there if you want. We also hold a special training conference around April, and that's for not only for basic training, but if you've already gone through a training process, it's also advanced classes. And so you're able to not only get training from us, but you're also able to network with other users of Rapidform to help you out.
Thanks, Mike. The next question is, what other software platforms can XOR LiveTransfer into?
If you take a look at XOR now, we can take a look at the LiveTransfer. You can see that not only do we do Creo, but also SolidWorks, Siemens NX, AutoCAD, and Inventor. And we have the capability of saving as CAD files, V4 and V5.
So can the software read in CAD files?
So in terms of importing files, take a look at that. You can see that we support a variety of files, but in terms specifically for CAD, we're able to import your IGES, your steps, your parasolids, and we are able to import native CAD files, SolidWorks, Pro-E, or CATIAs, but when that's brought in, that's bringing in just the model information, not the feature tree. We're not able to import the feature tree because it's pretty complicated. If we were able to, that'd be amazing. But unfortunately, the technology isn't quite there yet, at least development. So, but we are able to bring in native CAD files as well if need be.
Thanks, Mike. The next question is, how far back will Rapidform go with Pro-E compatibility to Wildfire 2, 3, 4?
If you go up here, you can see that we start off at Wildfire 3 and 4. So 3, 4, 5, as well as Creo 1 and Creo Parametric 2 will be supported in our next hotfix.
Thanks, Mike. That looks like that's it for the questions right now. And just want to make a note to everyone that this webinar will be available for viewing on our YouTube website as well as the Rapidform website as well. You'll be receiving an email here in the next couple days with a direct link to that replay. So if you want to watch it again or share it with someone, you're more than welcome to.
All right. Well, again, thank you for spending part of your day watching this webinar. Again, if you have any questions, feel free to give us a call. With that, I hope you guys have a great weekend.